I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
Space. Time.
the brain,
Life. The universe.
This week, the A to Zika of viruses, including where do new infections come from?
Plus, news of a soft skin that gives robots a sense of touch, why a lack of sleep can give you the munchies, and do cats always land on their feet? Or is that just a myth? I'm Kat Arney.
And I'm Chris Smith, and this is The Naked Scientists.
The Naked Scientists podcast is powered by ukfast.co.uk.
First this week, people who go through extreme and harrowing events often develop a condition called post-traumatic stress disorder, or PTSD. Sufferers describe intrusive flashbacks of the event that can even make them feel suicidal. But might a dose of laughing gas, nitrous oxide, given after a traumatic event, lower the risk of PTSD? Naked Scientist Georgia Mills spoke with UCL's Ravi Das, who has evidence to suggest that it might.
We were specifically looking at nitrous oxide because we know that one of the ways it acts is at a certain brain receptor that's critical in memory formation. And one of the main things that we think contributes to PTSD is the formation of these kind of traumatic memories that can resurface and cause these intrusive thoughts and images and flashbacks, which are kind of the cardinal symptom of PTSD. People can have the experience of being back at the time of the trauma, kind of context and situation free, and re-experiencing that event. So it's really unpleasant.
How did you test this? I'm guessing you couldn't actually give people PTSD. That sounds slightly unethical.
Yeah, that wouldn't have been a real hit with the ethics board. So we've got a kind of laboratory model of a very kind of weak form of PTSD, if you will. And it's used by quite a few labs. And basically it involves showing healthy volunteers a really unpleasant film. And what you see is over the course of a week, if you get people to keep track, they'll experience these kind of involuntary memories about aspects of the film that tend to be kind of images of some of the nasty things that have happened, and they'll just pop into people's minds in an involuntary way. And those are what we call intrusive memories. And so we show people this film and then measure over the following week how many times they're experiencing these. And we gave people either nitrous oxide gas, which is the same form that you'd get in the NHS. It's a product called Entanox. So it's mixed with oxygen, and it's a lot safer than the kind of gas canisters that people use recreationally. So they got that, or a matched kind of just normal air from a canister. And they breathed that for half an hour. And then we assessed for the following week how many of these intrusive thoughts they had.
Now, I've not seen this film, but I did look it up online and I read a couple of reviews, and one of them, they called it cinematic torture. And they said, I've yet to meet anyone who has not been deeply affected by this movie if they were brave enough or stupid enough to watch it. Your poor test subjects.
There's a problem with doing any studies that try to model something that's inherently unpleasant, in that you have to, within ethical bounds, give people something quite unpleasant to do. I did feel terrible for the participants while they were having to watch it.
Did you watch it?
Yeah, because much of the time you were sitting in the room with the participants, what kind of awkwardly knowing what they were having to go through. Yeah, I have to say I agree with some of the reviewers. It is one of the worst things I've ever seen.
And with the participants who got either this nitrous oxide mix or the control, which was air, what difference did you find with their feelings about the film?
What we kind of hypothesized was that given this receptor that nitrous oxide blocks is really important in kind of the transfer of information from short-term memory to long-term memory. So we thought that it would kind of prevent some of those memories stabilizing and weaken them. And what we saw is that by the second day, the people in the nitrous oxide group had greatly reduced in their number of kind of intrusive memories about the film, but the normal air group hadn't. And it wasn't until about 4 days later that we saw a significant reduction in those that had the normal air, but it was basically straight after sleeping in the nitrous oxide group. And we know that sleep is also really critical for this kind of stabilization of memories into the long term. So nitrous oxide seems to have interfered with that kind of sleep-dependent stabilization of of the memories.
Has nitrous oxide been tested in the field? Do we know if this works in these sort of real life events that might cause PTSD?
It's really interesting because it is used on the NHS currently in paramedic teams as a pre-hospital anaesthetic. So it might be having unforeseen consequences already for people who are receiving it. They might have already gone through quite a traumatic experience. We don't know currently whether that's subsequently affecting their memories. And one of the things we're interested in doing is looking to see if we can start monitoring the situations where people have received it before being admitted to hospital versus people who haven't. But in terms of I'm thinking maybe military application, all this is dependent obviously on our results being replicated in a clinical sample. But because it is easy to administer, it's portable, it's very safe. And once people stop breathing it, it stops having an effect very quickly. I don't see why it couldn't be kind of miniaturized and used as a kind of first line prophylactic type of intervention following traumatic events, yeah.
Ravi Das speaking with Georgia Mills, and that study came out this week in the journal Psychological Medicine.
Technology now, and a recipe for soft robotic skin that's sensitive to touch and has the ability to change colour a bit like an octopus has been developed by engineers in the US. This could pave the way for blushing robots and even 3D phone displays. Rob Shepherd told me how it came about.
There's a field now called soft robotics, and these machines are capable of working around humans safely, which is very important. But there are some things they can't do. Since their bodies are required to stretch to large degrees, we need electronics that can stretch with them. And some of the same students that were in my lab were taking a course on engineering with soft materials where I tasked them with coming up with a new device. And they, on their own, decided it would be great to impart light-emitting particles into these sensors. So now they created a device that can sense touch and also emit light in red, green, or blue.
Wow, so how does this work? Talk us through effectively what you have made and how it actually does that.
So this material is rubber. There are two different kinds of rubber. There's one rubber that doesn't conduct electricity and another one that does conduct current. And so by layering sheets of these, we can create the sensors and the light-emitting displays. And because it's all rubber, it stretches like rubber and is soft like rubber.
So how do you make the rubber conduct electricity?
So this technique actually was developed a couple of years ago at Harvard. And what they did is they put salt water inside of a rubber. And we took that material and layered it with an insulating material. And that composite is what gives us this new ability.
How does that architecture then, layers of a conducting rubber and a non-conducting, an insulating rubber, turn into something which A, can detect pressure and B, also make light?
Well, what you've just described, we call a capacitor. And when we can stretch the capacitor, we change the distance between the plates of the capacitor. That capacitance change results in a signal that we detect.
How do you get the light out, though?
Well, in the insulating rubber, we put light-emitting particles, and when we apply voltage across the plates, they emit light. One of the really cool features about the work is that it's made by casting a liquid and turning it into a rubber. Depending on how we cast it, we can have as many pixels as we like.
And then the application of this would be that if I built a robot with, say, a human hand-like structure, it would know when it was curving that surface around, say, my hand to shake my hand, it would know how much it was stretching and therefore how much force it was applying to my hand. So you wouldn't be in that ignominious situation where you've made a beautiful human-like robot that's capable of taking my arm off.
That's right. Since one of the major benefits of soft robots is that they can interact with humans safely, it's important to also let them feel what they're interacting with, and that's what this does.
How easy is that to achieve, though? You've done this in a small piece of material, but could you extrapolate this to a whole robot?
That's exactly what we're doing right now. So our next step is to put this skin onto a larger, more functional robot and test it out. And we believe it's very possible.
And now that you can get this beautiful lighting effect for free. I mean, lots of people wear makeup. Your robot could almost have sort of light-generated, self-made makeup, couldn't it? So it could even blush. But what's the application of being able to put the light in there as well? Why is that helpful?
Well, there's a few reasons. We make a point in the paper. There's two things this technology enables. One are robots that can change their color, and another are displays that change their shape. And you pointed actually to a very important point. Makeup is not useless. The ability to create an emotional response with the people you're interacting with is important. And we believe as robots work with people more, their ability to communicate information visually is very important, and that's what we can do with this technology.
Indeed. And that was Rob Shepherd. He's at Cornell University, and the work he was describing is published this week in the journal Science.
Hello, Greer Jackson here. I just wanted to interrupt and tell you what exciting things I have in store for the Naked Astronomy podcast this month. Take a listen to this. Scientists are calling this a revolution in the world of cosmology. It's a gravitational wave, of course. Join me, Greer Jackson, on Naked Astronomy to hear how this elusive phenomenon is making waves. It's available on most podcasting platforms or from nakedscientist.com/astronomy.
You're listening to The Naked Scientists with me, Kat Arney, and with Chris Smith. On the way, the surprising story of smallpox. And should scientists be engineering superviruses in the lab?
Before that, though, it's time to go from science fact to science fiction. And for this week's myth conception, Kat has been tackling a scientific piece of dogma about cats. What's this all about, Kat?
Groan. Well, at the risk of offending any of our cat-loving listeners, I'm much more of a dog person, so this week I've been finding out what happens when you throw a cat out of the window. Before anyone complains, no animals were harmed during the making of this radio show, but I did want to discover if it's true that cats always land on their feet, no matter how far they fall. So let's first take a look at what happens when they do make a successful four-footed touchdown, and then what goes wrong when they don't. Cats, along with other animals, including rats and rabbits, have something called an air righting reflex. This means that when they sense they're falling and they're the wrong way up, they will attempt to flip over in the air in the hope of landing feet first. And because cats have an unusually flexible spine and don't really have collarbones, they're able to do this really well. It happens like this. First they bend in the middle, so the front half of their body twists in the opposite direction to the back half. Next, they tuck in their front legs to make their front half twist further and faster, and stick out their back legs so their back half twists less. That gets the front half the right way up, front feet underneath, head on top. Then they switch round, tucking in their back legs and sticking out their front legs so the back half flips, so their feet face the floor. This cat righting reflex starts kicking in from when a kitten is about 3 or 4 weeks old, and by 6 to 7 weeks, they've got it nailed, ensuring a safe landing from a height of several stories. There are a few things that can interfere with this, though, and the first is falling from an insufficient height to execute their backflip manoeuvre. They need to drop at least half a metre or so to have enough room to do it. Experiments with rats have shown that alcohol interferes with the righting reflex by messing about with the balance sensing mechanisms in their ears. So if you got your cat drunk and then threw it out of the window, it might struggle to land neatly, but please don't try this at home. The other big question is, do cats always manage to land on their feet from any height? And do they always escape unscathed? The answers to this depend on how far it's falling and what it lands on. Cats can certainly break bones by landing on concrete or other hard surfaces from heights of more than about 10 metres. This is so-called high-rise syndrome, as they can't absorb the shock, regardless of landing on their feet or not. But if they fall from more than about 5 stories, something interesting happens. They hit what's known as terminal velocity, when they're falling as fast as gravity will let them. There's some suggestion that in this situation, once a cat has got itself the right way up, it will relax and spread out like a parachute, which might help to reduce injuries when it hits rock bottom. Intriguingly, a study in the 1980s looking at vet records of cats brought in after falls suggested 90% of animals falling from buildings survived. And in fact, their chances of surviving with fewer injuries were actually better if they fell from 6 or more stories than from lower heights, suggesting maybe the kitty parachute idea is true. Of course, there is an obvious alternative explanation. Animals falling from greater heights might be much more likely to be dead on arrival, so wouldn't be taken to the vet, skewing the statistics. And a more recent study showed that the further it falls, the more likely your moggy is to sustain serious injuries. So while it's true that cats can, usually, land on their feet, they don't always make it out unscathed, and in some cases reach the end of their, also mythical, 9 lives in a rather messy and tragic manner. Probably best to keep the windows shut if you want to keep your kitty in one piece.
Thank you very much, Kat. And if you at home have come across some suspect science that you would like Kat to investigate, then do please get in touch. It's chris@thenakedscientist.com. Now, meanwhile, I hope that you're not being kept awake at night worrying about bad science, because researchers have revealed this week that lack of sleep actually gives you the metabolic equivalent of the marijuana munchies. Erin Hanlon.
There's an association between insufficient sleep or short sleep and the increased risk of obesity. And there's been some carefully controlled laboratories that have shown that when people are sleep restricted, they are reporting feeling hungrier and having a stronger appetite, mostly specifically for high carbohydrate and high fat foods. So we wanted to examine what might be causing this increase in appetite and further help to explain the current association with the increased risk of obesity following sleep restriction.
And just to be clear, the increased appetite that's measured in these people, that's not just because if you're awake for longer, you're functioning for longer, you need more energy, therefore you compensate by eating more.
Correct. So the energy need of being awake longer is actually quite modest. And studies have started to show that people are consuming more calories than are actually needed to maintain wakefulness.
So something else is going on driving people who are in a state of sleep deprivation to overeat.
Exactly. That's exactly it.
But we don't know what it is as yet.
Right. Well, we're starting to kind of tease those things apart. It's probably a lot of things working in concert, and our current study is adding to this growing literature and suggests one pathway by which this might be occurring.
What did you do to explore it, and what is that pathway?
Right. So we brought people into the laboratory. We had them sleep either 8.5 hours a night or 4.5 hours a night. And we examined a system that is involved in many areas. It's involved in stress, the immune system, pain, reward, and specifically reward-driven eating or hedonic eating. So we explored this system, and it's actually called the endocannabinoid system. And following normal sleep, we found that blood concentrations of lipids that are involved in this system are low overnight and high during the day. And when these individuals were sleep restricted, during the day, those levels were even higher.
You're hypothesizing then that those are driving the increased appetite that these people display?
That's what we think, because the endocannabinoid system has been known to be involved in overeating and actually overeating highly palatable foods. So it's been thought that this system was involved in brain reward pathways and might affect eating behavior via reward circuitry. So seeing this increase in blood concentrations suggests that this system might be overactive following a state of sleep restriction.
In other words, sleep restriction could be mimicking the marijuana munchies, the idea that people who use cannabis also tend to report getting hungrier and eating more and a tendency towards being overweight.
Exactly. So marijuana activates the endocannabinoid system as well. So we think that perhaps sleep restriction, just like marijuana usage, is activating the endocannabinoid system to cause overeating and overeating of highly palatable, rewarding foods.
Why?
I don't know.
What do we think the benefit of that? Is that just because if you are sleep deprived, you're more likely to be a bit less motivated, a bit more tired, a bit sluggish, therefore making sure you feel like you want to keep eating and stay at the top of your energy game means you're less likely to become someone else's lunch in our evolutionary history? Is that the idea?
I mean, it was probably protective at some point in a state of feast or famine when you had to overeat to have energy stores for other times when you might not have access to food. But it's become a little bit maladaptive, likely.
Where does this leave us? What do we have to ask now? And does this help us to solve the problem for people who do gain weight because they're not getting enough sleep?
Right. I don't think it actually will solve the problem, but I hope it draws attention to the fact that sleep restriction and sleep deficiency is associated with a lot of negative outcomes, and increased feeding just happens to be one of them. So hopefully this draws attention to the fact that we need to think of adequate sleep as an important aspect of maintaining good health and not just kind of as a byproduct of the day.
So there you go, a great excuse to have a nap instead of going for a run, if ever I heard one. That was Erin Hanlon from the University of Chicago. She published that work, appropriately enough, in the journal Sleep.
Most scientific studies last for a matter of hours or days, but there's one very important medical study that's probably the longest running of them all, and this week it celebrated its 70th birthday, along with the surviving study participants, all 3,000 of them from around the UK. They've been sharing their health and lifestyle data across their lifetimes with a team of MRC scientists at University College London. Connie Orbach has been hearing what the study has achieved and began by dropping in on one of the study participants, Tony Miles, who lives in Cambridgeshire.
One of the female participants had a boyfriend who became a fiancé, I think, and she had a load of data from the survey arrive and was answering the questionnaire and stuff like that. And he approached her and said, "Why are you answering all these questions? These are all Nosy Parker things," and threw everything in the bin. Okay. But she thought, if he thinks like that, he's not going to be the husband for me, and ditched him. And thanks the study for not marrying the wrong bloke.
And she still thinks it was a good decision, then?
Of course.
They've had wider-reaching effects than maybe even they realised would happen. Relationships aside, this study has had some really important impacts since it was established in 1946, especially as it was the first ever one. Diana Q, director of the cohort study, aka the MRC National Survey of Health and Development at UCL, explains.
Britain really led the way. This was the first of the national birth cohorts. We're known around the world for these cohort studies, and over the years there have been other countries who've also started off birth cohort studies in Europe, in America, and now in quite a few of the low-income countries. And we learn a lot by comparing across these studies. So you can see whether findings in one cohort are actually, do you find the same? Can you replicate those? Because that is very important for policy, for the impact of the information, if we can show that we find the same associations across these studies.
You explained how the very initial study really fed into the foundation of the NHS, especially in maternity. What are the other kind of big findings over the years that's really affected our policy, the way that Britain works?
Let me pick just two. When they were children, they did quite detailed cognitive tests. So we knew when they were age 8, for example, how well they were doing cognitively. And then James Douglas followed them up. Those who, did they get through the 11 plus? Did they go on to get educational qualifications and such like? And children who were apparently very cognitively able but came from poorer backgrounds had much less chance of benefiting from their cognition, if you like, in later life and getting into good jobs or schools or whatever. And that was called the wastage of talent. And it really important that we invest in children, in their health and education, because they are the future generation. So a lot of the study findings went into commissions looking at policy reform for education in the 60s and 70s. Now we're very interested in their aging, and we can identify people who may be having an accelerated aging process earlier, people who may be more susceptible to certain types of aging trajectories. And I think we need to be making sure we get in early and not waiting until people already have a lot of chronic diseases and problems and functional decline. And I think that's the future, and our information is being used to help.
This study has clearly had far-reaching consequences, but it's not just about the way it has changed public policy. It has also dramatically impacted the lives of the people taking part. Here's Tony again.
The team are forever thankful. The research scientists have so much data and they use everything they've discovered in a wide-ranging way. We're a perfect group to see how well we've developed and now how well we are. And having them thank us all the time like that does make you think, oh, I'm glad I've done that, glad I've stayed in that study doing that.
Well, happy birthday, Tony, and all the other participants. Thank you all for your help. And as a birthday present, it seems that the latest results have some good news for later life.
In the same group of people, when we asked, did a well-being scale in their early 60s and have just repeated it, on average, people's well-being has been going up on all the different aspects that we ask about. And there is a group who we're particularly interested in who have actually had a significant increase in their well-being. When we spoke about that at the 70th birthday party, and two study members shouted from the audience, retirement.
They've got a good point. That's Naked Scientist Connie Orbach speaking to the director of the 1946 birth cohort study, Diana Q. And before her, you heard study participant Tony Miles.
Thank you, Kat. And up next, where new viruses come from and how can we wipe them out?
What you end up with is, in effect, this sequence that you've added, precisely inserted in the targeted position in the genome.
In this month's Naked Genetics podcast, we look at the hottest new biotechnology technique to hit the headlines since forever. CRISPR has big implications for health, plus linking genetics to lifestyle, and our gene of the month is black and white and very cute. Listen and download now at nakedscientist.com/genetics.
You're listening to The Naked Scientist with me, Chris Smith, and also with Kat Arney. Now, this week we're going to be looking at new and emerging infections, which to some of you may sound familiar. Now, on to the main theme for this week, and that's Ebola. Ebola has been dominating the headlines for many months, with governments and healthcare providers worldwide caught off guard by the outbreak in West Africa. That was 2014, when we looked at Ebola. Now, different year, different virus, and it's Zika which is dominating the headlines, with the WHO declaring it a public health emergency back in February.
And it's not just Zika at our door. Between them, the bacterial infection TB, the parasitic illness malaria, and the AIDS virus are wiping out 5 million of us every year. That's about 300 people just in the time you've been listening to this programme.
So for the rest of the show, we're going to be looking at humanity's fight to keep one step ahead of bugs like these, including why nobody saw Zika coming, whether we can eradicate any of these diseases for good, and the controversy behind why some scientists think we should be engineering superviruses.
But we begin with a disease dubbed the Angel of Death, reputed to have brought down entire dynasties through history. Thankfully, it's since then become the first disease we've managed to eradicate. Here's Georgia Mills.
I wanted to hear the story of how smallpox went from being one of the world's deadliest diseases to being one of science's greatest success stories. So I went to meet medical historian and author of the book Murderous Contagion, Dr. Mary Dobson at Cambridge University Farm, to find out about this disease.
It really was a devastating disease. People would be covered in horrible pustules. They would be exceptionally painful. Some would die from a sort of hemorrhagic fever. Probably a third of those who contracted smallpox would die. Survivors could be pockmarked for the rest of their lives. And I think an unknown, not often mentioned, is blindness. So again, those who survived could be blind for life.
With such a frightening prognosis, smallpox left a significant mark on history. British historian Lord Macaulay made this observation in the 1800s.
The smallpox was always present, filling the churchyards with corpses, tormenting with constant fears all whom it had not yet stricken, leaving on those whose lives it spared the hideous traces of its power, turning the babe into a changeling at which the mother shuddered, and making the eyes and cheeks of the betrothed maiden the objects of horror to the lover.
It impacted the rich and poor alike, knowing no class boundaries. Ancient Egyptian pharaoh Ramesses V, Abraham Lincoln, and even Mozart all contracted smallpox. So how did people try and escape this dreaded disease?
I think smallpox is an interesting case because people were aware that it was contagious. So prevention was one of trying to avoid being close to a contagious person. Bloodletting was the cure for almost everything in the old days, right up to the sort of mid-19th century. It would have done very, very little good for anyone suffering from smallpox. So not a lot that they could do, but, I mean, numerous old remedies are concocted.
I think I read one that was powdered horse manure.
Yes, powdered horse manure is one of those good old-fashioned remedies. I mean, anything from garlic to alcohol or herbs. Around the 10th century in China, it was said that they removed scabs from the drying pustules of a smallpox patient, pounded them into powder, and then blew a few grains into the nose of people who had not had the illness.
Oh.
Yes, and one of the things that amuses me is up the right nostril for a boy and the left one for a girl.
Of course.
Of course. Who knows why?
This idea of infecting healthy people intentionally with small parts of the virus did actually work to some extent. But what came next in the fight against smallpox changed everything: the vaccination. And it's at this point we meet a key player in the story, the humble cow. Or rather, we met about 30 of them, including one very bold character who wanted to join in with the interview. Trying to eat the microphone. No. But what do cows have to do with the smallpox vaccine?
Well, you could actually say vaccination. The word vaccination is from vacca, which is the Latin for cow. The discovery of vaccination, which is credited to Edward Jenner in 1796, is because he took up a local story that milkmaids who contracted something called cowpox, possibly from infected udders of cows, were immune to smallpox. And after some years, he took a very, very brave decision to try out an experiment. And there was a young girl, a milkmaid, Sarah Nelms, who had cowpox. And so he took from one of her pustules, from the cowpox, some of the matter, and he then used the son of his gardener, a young boy called James Phipps, and he scratched some of the pus into James Phipps. 6 weeks later, he inoculated smallpox virus, living virus, into James Phipps to see whether the cowpox had indeed protected him. And the result was James Phipps did not get smallpox.
Cowpox was a similar virus to smallpox, but much less dangerous. So once this boy's immune system learnt to recognise it, smallpox no longer held a threat. Ladies and gentlemen, the world's first vaccine. After initial rejection from his peers at the Royal Society, Jenner's ideas took off and vaccines made their way all across the world, starting in Gloucestershire, ending up in Europe, Russia, and making it all the way to the Far East. But even though these vaccines saved millions, people were still contracting the disease right up until the 1900s.
So in the 1960s, we've got about 10 to 15 million people contracting smallpox a year, probably about 2 million deaths. So the World Health Organization took this as a very serious threat. There was a vote, and it only went ahead by 2 votes to embark on an intensified 10-year smallpox eradication program. And initially they started with mass vaccination, so the idea was to just vaccinate everybody. A new technique was freeze-dried vaccine, which was good for tropical climates. And actually South America was free by 1972. But Africa and Asia, formidable barriers. I look back and reading the accounts of those dedicated workers who crossed jungles, rivers, reached outlying rural communities to try and vaccinate communities. It is an incredible story, and they were heroic, absolutely heroic. And It was also a campaign that transcended ideological and political boundaries. It was during the Cold War, and actually the US and the Soviet Union fully cooperated, so I think that was really interesting. 1979, the WHO, the World Health Organization, based in Geneva, announced eradication. A momentous, absolutely momentous timing. And one of the perhaps saddest twists to the smallpox eradication success is that 1980 it's eliminated from the list of world infectious diseases. 1981, a year later, we hear of the first cases of HIV/AIDS. I find it really very sad, that juxtaposition between this incredible success story and the sadness with which the HIV/AIDS story broke in the 1980s.
And that's a theme we'll come back to later in the programme. Mary Dobson there, down on the farm with Georgia Mills. So with smallpox confined to the annals of history, can we do this again with other diseases? Well, the answer is possibly. And one virus we're actually very much closer to eradicating than ever before is polio, which can cause a fatal paralysing illness in its victims. Jonathan Ball is the Professor of Molecular Virology at the University of Nottingham and is with us now. Hello, Jonathan.
Hi.
And why is it we think polio is a good candidate for eradication?
Well, there are two main things that we really look for in a virus that could be eradicated. The first is that we have an effective vaccine, so vaccinations are really key. And so that's to generate immunity in the population that protects them from a future infection. But the other key thing is the fact that this is a virus that only infects humans. And so there's not a massive animal reservoir out there that we have to worry about where the virus can continue to spill out and infect humans.
What progress has been made so far towards getting rid of polio?
There's been fantastic progress. So towards the end of the 1980s, WHO decided that, this was really something that we could achieve. And so they ramped up vaccination efforts. And so it's important to vaccinate young children. Since the advent of the vaccination program, we've seen huge decreases in the number of polio cases. We're left at the moment with only 2 countries where the virus is what we call endemic. So that means that the virus is circulating in those human populations unhindered. And those 2 countries are Pakistan and Afghanistan. And some of the problems that we have with that, because you have virus circulating in those countries, it means that occasionally that virus can be exported to other parts of the world, so that we saw recently a virus being exported from those regions into Syria with insurgent fighters, and then that virus spilt over into Israel. So it's really difficult to control.
Why are both of those countries hotspots for polio still?
The bottom line is that these are countries where there's a lot of civil unrest, particularly the northern parts of Pakistan and of course, Afghanistan. There's huge problems, and with civil unrest, with war, etc., are a wonderful breeding ground for viruses. And it means that it's very difficult for people to carry out these vaccination programs. And I mean, if we take Pakistan, for example, this was a country where we thought that Osama bin Laden was holed up. And in fact, as it turns out, that is where he was holed up. But the Americans, the CIA, apparently set up some kind of spoof vaccination programs. This was hepatitis B vaccines. But what they did was they recruited a doctor who set up these vaccination programs to try and get DNA samples so that they could see whether or not Osama bin Laden and his family were living in the place that they thought he was holed up. And that caused mistrust in Pakistan, and therefore they felt that these vaccination programs were a weapon of the West, and so they were very, very cautious and very suspicious of the vaccination people, and indeed many of them lost their lives trying to carry out vaccinations in that area. Thankfully, things seem to be resolving and the programs are going full steam ahead.
Is it looking promising then? Do you think that we're going to prevail and we will see the end of polio?
I think so, but it really is a problem that has to be nailed, because if you have any virus which is circulating, that poses a huge risk, certainly to surrounding countries. But we travel a lot, and people travel, and therefore the virus can travel. So eradication, it really has to be full steam ahead. Otherwise, we'll see this virus smouldering on, and it will spread.
Can we apply the learning which we have gained from the eradication of smallpox, from the near eradication of polio, and turn our attention to other viruses which are big health threats? What else is on your wish list of potential viruses to get rid of?
Well, the two that spring to mind immediately, the first one is HIV, and the approach there isn't vaccination. We know that this is a virus that has been incredibly difficult to develop a vaccine. And so what United Nations are hoping to do is to be able to eradicate this virus through treatment. So that's to treat people who are infected so that they can no longer spread the virus, because we know that the virus spread is related to how much virus is circulating or being produced in a person. And therefore, by treating them, they hope to reduce the amount of virus and therefore reduce the risk of onward transmission. And also to use drugs to prevent infection. It's a very ambitious aim. They hope to eradicate the virus within the next 15 years, and time will tell if we achieve that. But the other virus that really springs to mind is rabies virus, and this is a virus that could be eradicated through vaccination.
But rabies is carried by animals as well, isn't it? So isn't that against the rationale that you put forward earlier, that you need something to be a human infection exclusively to get rid of it?
Yes, well spotted. And really the key here is we couldn't imagine eradication in those animal reservoirs, or certainly not in bats. But in terms of classical rabies, this is a virus that circulates in mammals, for example, dogs and foxes and wolves and things like that. It is possible to eradicate that virus because we know that there are vaccination programs that have worked in the past where they were able to lace food baits with rabies vaccine, leave it out for the wild animals to eat, and when they were eating this free meal, they became vaccinated. And so they've been able to eradicate the virus from the wildlife populations, and therefore you reduce the risk to humans. But any virus which we have an effective vaccine should really be on our radar for eradication.
Jonathan, thank you very much. That's Jonathan Ball, who's a virologist at the University of Nottingham.
This week, we're discussing where new infections come from and how to get rid of them. One way that new viruses can appear is if scientists create them in the laboratory. Researchers often genetically modify organisms in order to discover how they work and how they cause disease at a molecular level. And famously, a few years ago, researchers in the Netherlands and the US made forms of H5N1 influenza, or bird flu, that had a 70% fatality rate and the ability to spread very efficiently between mammals, including us humans. So, should we be scared? And should this even be allowed? To discuss, we're joined by Philippa Lentsos. She's an expert on biosecurity from King's College London. So, Philippa, can you explain to me what were the scientists doing here and why on earth were they doing it?
Hi, Kat. Well, broadly what these two labs were trying to do was to understand the factors that determine the ability of animal viruses to spread to humans. So what they did was to mutate the H5N1 bird flu virus to make it airborne and transmissible to mammals, and as you said, including humans.
So it doesn't normally travel in the air, but they made it so that it could survive in the air and get from animal to person.
Exactly right. And that mutated virus was highly virulent and as efficiently transmitted as a common cold.
Now that sounds like a bad thing to be doing. Why on earth did they even want to try and do this?
Well, I mean, this is part of, a lot of this is part of basic science. New and emerging infectious diseases are also considered some of the biggest threats to national security. But we're unable to predict which specific virus subtype will trigger the next pandemic. So it's really in order to address the knowledge gap and to understand flu transmission, aid detection, prepare vaccines, that sort of thing.
So effectively, they were trying to make stuff in the lab that could have happened in real life to work out, OK, can we figure out what might these viruses be like if they do arise in the real world out there?
Exactly right. They were figuring out or trying to work out what might happen in the future and how we would then respond to that.
So this does sound quite risky, though. How risky is it? Is there a chance that these kind of things could escape? Almost you get the impression of a mad scientist in their lab going, I'm going to make a killer virus. What are the controls and the checks and balances here?
There certainly are a number of risks against this, and enhanced viruses, as you said, could be accidentally released. they could also be intentionally released from a lab. In that sense, they would potentially expose the surrounding populations to pandemic pathogens.
What are the kind of mitigations against this? It just bothers me a little bit to know that researchers are building these things in labs. How are they protected?
Well, currently they work under biosafety containment precautions, but in response to the experiment we were talking about, the H5N1 experiment that was done a few years ago, what happened was the scientists broke the news pre-publication, pre-review in the media. And it was met with substantial alarm from the scientific community.
Yeah, not surprising.
No, I mean, the New York Times went with the kind of the headline, "An engineer doomsday." This was really a big deal. The advisory body in the US that was looking at this advised against publishing the methods section because that might give information to people who would misuse it.
Nefarious people. And then I understand that then funding was stopped for this kind of research. I mean, where are we now with attitudes towards actually doing and funding this kind of research?
Initially, there was a self-imposed voluntary moratorium by the scientific community on this. That was lifted in 2013. That then became entangled with, safety concerns, and there were a couple of high-profile lab safety breaches at the time. And eventually, the US government stepped in October 2014 and pulled their funding on this gain-of-function research of concern. So it was particular subtype of gain-of-function research that they pulled their funding on, and they started this deliberative pause. And that's what we're coming to the end of now.
So there's a debate, I understand, happening in Washington this week to say, so should we do this? How do we go forward? What's going on there?
Well, the debate is really about risk assessment of this gain-of-function work and about who should be making those assessments. Should it just be scientists? Should it be their institutions? Should it be funders? Should it be publishers? Or much more broadly, should it be regulators, vaccine manufacturers, ethicists? These are big questions.
Because I guess we've always got to balance the benefits of finding out how these viruses could potentially happen and work with the risks that we might accidentally cause a pandemic. So should researchers be allowed to do this?
Well, there will be cases where the risks outweigh the benefits. And there are experiments that simply should not be done.
What kind of things would that be?
So, for instance, making Ebola airborne, making influenza viruses resistant to vaccines or antivirals. So I think we need clear red lines about this, and we need a regulatory framework that also applies to the military and to commercial sectors, and that isn't just limited to those in receipt of NIH funds, which is the current situation in the United States.
Thanks very much. So certainly one to debate for the future. That's Philippa Lentzos from King's College London.
Certainly food for thought. Now, earlier on in the programme, we heard that the year after smallpox was officially declared as eradicated, HIV then comes along and enters the public consciousness. But why do new diseases like HIV abruptly appear? And why, for that matter, do old diseases, which have been around for decades but at a very low level, suddenly become a problem? Well, Colin Russell studies the dynamics of emerging infections at Cambridge University, and he's with us now. Hello, Colin. Where do these diseases emerge from?
There's a huge diversity of pathogens that infect animals all around the world. And when those pathogens start infecting humans and evolve the capacity to transmit efficiently from human to human, we have these big, dramatic outbreaks.
And taking sort of Zika as an example of this, we've known about Zika for a long time. So what's changed to make Zika suddenly start spreading and infecting people the way it has?
Goodness, Chris, if I knew the answer to that, I'd be at home writing a paper right now. The short answer is we don't know. And it's one of the critical questions that people are looking into right now, which is we've seen this virus and we've known that it infected humans for a long time. But historically, it's largely been a mild infection. And now, suddenly, it appears to be causing severe disease. But we don't understand what's changed.
So something has to either change in the bug itself, or something changes in the environment the bug inhabits, or something changes more broadly on the scale of the whole planet and us, which kind of adjusts or tips the balance.
Yes. Well, so I mean, if we look at smallpox, for example, smallpox circulated in Europe for hundreds and hundreds of years. But before European explorers went to the Americas, smallpox wasn't in the Americas. And when European explorers went to the Americas, they introduced smallpox, and smallpox literally decimated the North American populations. And so there is that possibility for the access to a new population that can facilitate this sudden dramatic sort of outbreak.
Some people have speculated that what we're seeing in Brazil could have been the result of an introduction to the country in sporting teams, either for the World Cup or people in rowing competitions from Pacific Islands where Zika was circulating.
So one of the things that researchers are looking into right now is how and when did the virus first make it to the Americas? So it was known to be circulating in parts of French Polynesia and other Pacific islands. And at some point, that virus was introduced into the Americas. We don't know when, we don't know how many times, but by virtue of the fact that we're an increasingly globally connected world where people are traveling all over the world all the time, the possibility for introducing new diseases is always present. And there are so many different viruses that are circulating in animal populations all over the world that the more we look at those viruses, the more viruses we ultimately see. And we get a very difficult challenge there of then anticipating which one of them is most likely to start causing problems for humans. Because the vast majority of them, at least right now, don't.
And therefore, what should we be doing to protect ourselves?
So this is actually a really complicated issue because the places where emerging infectious diseases are most likely to first enter the human population, these are the places that are least capable of actually dealing with these emergence events. So if we think about the UK, for example, we see very few actually emerging infections, and that's largely a product of the fact that we have very limited interactions with animals. I've seen no wild animals today. I don't have any chickens living in my home. I haven't seen a pig in months. But the simple fact is that in many portions of the world, that's very different. It's a situation like that where you have really close interactions between animals and humans that these viruses are most likely to emerge.
So we've got a wonderful laboratory network in Western countries like America, like the UK, Australia, and they're doing a great job of protecting countries where the risk is already low. And what we need is to have that sort of network in countries where the risk is high.
So there's two things. The first is we need to identify the places that are actually risky. I mean,
Do we not know them then?
No one has done that precise sort of risk estimate across a wide variety of diseases. But once we do identify those high-risk areas, we have to develop the basic public health infrastructure that allows people to differentiate ordinary from extraordinary. Because in many portions of West Africa, for example, if you show up at a doctor's office and you have anything that might be considered malaria, you're told you have malaria, go home. But the simple fact is that there are probably people who are told that they have malaria and they in fact have something that's absolutely not malaria.
I think the first man ever to have Ebola was a school teacher who came home with a bad fever and was told, you have malaria. And he then infected the entire medical team, his family and a village, and hundreds of people were spawned by that case. So you're absolutely right. So are you saying then that people need to be better at diagnosing these things and spotting these things sooner?
Yes, absolutely. But that's not a trivial undertaking. Because to be able to make that kind of diagnosis that differentiates something that you see every day from something that's actually kind of different, it requires diagnostic tools that just don't exist in most portions of the world.
We don't really skimp on spending on defence when it comes to worrying about warding off a marauding force from overseas. Could we not regard this as a form of defence, and perhaps we should spend a little bit of that money on those sorts of resources you're advocating on the ground in these foreign countries? Because at the end of the day, if something is spawned there, it can sure as hell come anywhere to roost, couldn't it?
Absolutely. High-income countries effectively have to see emerging infectious diseases as a real defense threat. And this is becoming increasingly pervasive, particularly in the United States, where infectious diseases are being more widely regarded as a threat to national security. But it's very much the case, because in these places where the diseases are most likely to emerge, if we invest more in detecting those viruses or bacteria or whatever ends up causing disease, if we invest more there's a greater chance that we can stop it before it comes here.
Colin, thank you very much. That's Colin Russell from the University of Cambridge.
So from future threats to humanity, let's go back to where our story started. Even if we can eradicate diseases like smallpox, are they ever really gone? Smallpox may have been wiped out, but the virus that causes it still exists in 2 labs in America and Russia. So why haven't we destroyed them? Georgia Mills is back with the end of smallpox's story.
I'm here to see Professor Smith.
What did I say?
signing the register? Sure.
So I'm Geoffrey Smith. I'm head of the Department of Pathology, and I'm a Wellcome Trust Principal Research Fellow. It might sound logical that at the end of a disease eradication program, the virus that causes that disease should also be eradicated, and many people took that view. Other people, however, argued that we didn't really understand why that virus was able to cause such a devastating disease in man, and if we conducted further research on that virus and gained that understanding, that would be helpful not only for perhaps treating and preventing other pox virus infections, but other virus infections in general. And so in 1996, the World Health Assembly adopted a recommendation made by the Orthopoxvirus Committee that advised the WHO that all the remaining virus should be destroyed. So that recommendation was made in 1996, and the World Health Assembly debated it and passed that resolution. And the date for destruction was set in 1999, and that date came and went, and the destruction did not take place.
So what happened? Well, there was a postponement so that 3 lines of research that needed the virus could be continued. These were producing diagnostic tests for future cases of smallpox, creating a safer vaccine, and making antiviral drugs so the disease could be treated. But if the virus that causes smallpox, called variola, was destroyed, why would we need drugs to treat it?
I think the reason that some nation states wanted to develop drugs was the fear that actually the virus might exist somewhere else. And I think it was following the attacks in the USA in 9/11 that the US government, for instance, felt that if people were prepared to fly aeroplanes into densely populated buildings, then would they stop at using a virus of this type as a bioterror weapon if they were able to get their hands on it.
So are there any risks to having these remain in the USA and Russia?
Well, there is certainly a finite risk in keeping a virus. I mean, you have to maintain the security. I'd have to say that security is very good, and both these facilities are inspected regularly by WHO authorised teams, and I think the chances of the virus getting out of either place is remote. More of a concern would be that it's out there somewhere else that we don't know about already, or that it could be remade.
Some argue that if the virus could be remade anyway, there's no reason not to destroy the samples, but others argue this would be premature and we still have a lot to learn from them. Geoffrey chairs the WHO's Advisory Committee on Variola Virus, who meet to discuss the need to continue this research. So I asked him, will we ever be closing the book on smallpox for good?
The decision to destroy the virus is taken is not a case of if, it's only a case of when.
Georgia Mills speaking to Professor Geoffrey Smith. And thanks very much to all our guests, Colin Russell, Jonathan Ball, Mary Dobson and Philippa Lentsos.
You're listening to The Naked Scientists with me, Chris Smith, and also with Kat Arney. If you want to find us on Twitter, it's @NakedScientists, or to contact the programme, chris@thenakedscientists.com.
And now it's time for our question of the week, and Felicity Bedford found herself attracted to this question from Erica.
The Naked Scientists Question of the Week, brought to you in association with the How to Wisman Foundation, supporting science and education from alpha to omega.
How do pheromones work in humans?
I spoke to Tristram Wyatt from Oxford University, who explained how we use our noses to sniff out our perfect partner.
Well, there's a lovely Swiss study from the 1990s where male students were asked to wear T-shirts for a couple of days, and then female students sniffed the T-shirts without the male student in them and rated them for attractiveness. And then the researchers tissue typed everybody involved, and they found something surprising.
What, that most people were picking the most hygienic male in the room?
Not at all. In fact, some of the smelliest T-shirts were attractive. But what made them attractive was not the smelliness or lack of smell. It was whether or not the man wearing the T-shirt had been immunologically different or the same as the woman who was sniffing. And what the researchers found is that the women found most attractive the T-shirts worn by men who would be terrible kidney donors. In other words, they're immunologically different, but would actually be very good fathers for their potential children.
Are these smells pheromones?
These smells are not pheromones because they're individually different. Pheromones are the smells that are given off in the same way by all males or all females. So they're chemical signals and they signify maleness. So it wouldn't give you much to choose between males. Some might have more than others, but a male with the most might not necessarily be the one who's most compatible with you on an individual basis.
Do humans have pheromones? I know that they're found across the animal kingdom.
Humans might have pheromones, but despite everything you'll see on the web, the evidence is really poor. And a lot of it goes back to a corporation which claimed we did and tried to make money from selling them.
If we have pheromones, they're probably important for an awful lot of things in our life, but we haven't identified them yet. And for the moment, if you're trying to work out whether a mate is suitable, it's more about the smell rather than pheromones.
And really, I think, get into conversation. Finding a potential partner is not only hard, it's complicated. And there are so many things that come into play. It's whether they make us laugh, whether we think they're attractive. You can even fall in love with a photo. And that's one reason that we love going to the movies.
So if you're looking for love, best to use all your senses, including your nose. Thanks, Tristram. Our next question is from Jonathan.
Is it technically possible for two planets to share the same orbit, as in exact polar opposites to each other, and travelling at the same speed?
What do you think? You can email Chris at thenakedscientist.com, find us on Facebook, tweet at Naked Scientists, or join the debate on the forum, nakedscientist.com/forum.
And that brings us to the end of the programme. Thank you very much to Georgia Mills for production. Do join us next time when we're going to be celebrating the Cambridge Science Festival with an explosive romp through some of the most exciting science the festival has to offer. The Naked Scientist comes to you from Cambridge University. It's supported by the STFC, the EPSRC and Rolls-Royce. I'm Chris Smith, and thank you very much for listening. Goodbye.